So we've been talking about the way the body breaks down triacylglycerols and then subsequently the fatty acids that are produced from that to provide energy for basic metabolic needs. Now, in an ideal scenario, you'll hopefully recall that the beta oxidation of fatty acids yields the molecule acetyl-CoA. That acetyl-CoA, under ideal conditions, could then enter into the citric acid cycle and be broken down and eventually converted into carbon dioxide and water. Under some conditions, when carbohydrates are not available for the body to use as fuel, the body has to resort to using lipids to meet the majority of the energy needs. Now, the problem with using exclusively lipids to meet energy needs is that there can be an overabundance or an excessive amount of acetyl-CoA produced as fatty acids are being oxidized. So in that case, the body will respond to that accumulation of acetyl-CoA by producing molecules that are referred to as ketone bodies. Now, what will happen as acetyl-CoA accumulates? The first reaction in forming ketone bodies is basically the reversal of the last reaction of beta oxidation. So we take two acetyl-CoA molecules and we can bind them back together to make the molecule aceto-acetyl-CoA, which is basically two acetyl groups connected together with a coenzyme A molecule. Now, what will happen will be the removal of coenzyme A and the production of the first ketone body referred to as acetoacetate. Now, you'll notice, hopefully, that there are two double bond O's present here. One of them is strictly a ketone, which is where the ketone body term is derived. The other double bond O is a part of our carboxyl group. Now, this carboxyl group can be removed as carbon dioxide, and in that case, the molecule then is converted to acetone. The other molecule that can be produced is, again, it's going to require the utilization of NADH. It's going to reduce this double bond O to an OH. And this molecule, although it doesn't have a ketone group specifically, it's still referred to as a ketone body. And its name is beta hydroxy, because of the hydroxyl group here, butyrate, because of the 4-carbon molecule. So again, both of these, I hope that you can notice that both of these molecules have carboxyl groups. And again, the carboxyl group has already donated the proton to form the negative ion. Now, what this means is that and the release of the proton means that these molecules and the production of a lot of these ketone bodies can actually have an impact on blood pH. But this is the kind of reaction that will take place when the body is utilizing a large amount of lipids to provide for the energy needs of the body. Now, this is going to occur in a couple of different conditions that we'll talk about. We're certainly going to talk about starvation in quite a bit of detail a little bit later on, but starvation is going to be one time when the body is going to be utilizing or looking to lipids to provide energy for normal metabolic activities. Another state, it's actually a diseased state, is the condition of diabetes, and we'll talk a little bit about that in a minute. Another possibility of when this ketosis or the production of ketone bodies can occur is when one has a diet that is very high in fat and very low in carbohydrates. So this is going to be, have been some trends over the past years where people have decided to intake very low amounts of carbohydrates in the hopes that the body will look to fat stores and utilize fat stores for energy. But the problem is, in all of these conditions, is the reality that the accumulation of ketone bodies will occur as the body looks to lipids as the primary fuel source. Now, what that eventually can mean under extreme conditions is that the blood pH can be altered, and because of the acidic properties of ketone bodies, the blood pH can actually go below a value of 7.4. Now, below that value is referred to as the condition of acidosis. In other words, the blood pH gets low enough that it can actually cause damage to tissues. So during the condition of diabetes, the body is unable to utilize insulin properly. Now, remember that under normal conditions, when blood glucose increases, insulin is secreted by the pancreas, and the secretion of that insulin is a signal to cells to take up glucose and either utilize it as fuel or store it as glycogen. So in high blood glucose levels, the liver is going to take extra glucose and store that as glycogen. Now, as it does that, eventually the blood glucose levels will decrease. Now, when blood glucose levels get below a certain value, the pancreas will secrete glucagon. Then glucagon will then signal to the liver to supply glucose into the blood for use by red blood cells or the brain. So the liver will take glycogen molecules, break it down one glucose molecule at a time, and it'll take those glucose molecules, put them back into the blood to increase blood glucose levels. Now, the problem in diabetes is that insulin is no longer functioning in its normal capacity. So what that means is that in type 1 diabetes, insulin is no longer produced. And so the cells never get the signal to take up glucose and store it for later. So what happens is the body, even though glucose may be present, the glucose is unable to provide the energy needs for the cells of the body because it can't be taken up by the cells. So under those conditions, the body is going to resort to fats. So fats are going to be broken down, and as fats are broken down, the amount of acetyl-CoA in cells, particularly in the liver, is going to increase. And as those acetyl-CoA levels increase, then the ketone, the ketogenesis or the ketone body formation is going to take place. A similar condition is going to occur during starvation, again because carbohydrates aren't available as a fuel option. So we'll talk about that a little bit later on. But in all of these cases, whether it's diabetes, starvation, or whether it's a diet that is intentionally eliminating carbohydrates, in all of those conditions, fats are going to be utilized as fuel, and acetyl-CoA will become a major molecular byproduct as those energy needs are trying to be met by the cells. So go ahead and take a little bit of time to process through this, and then again we'll revisit this a little bit whenever we get to starvation in a couple of weeks.